Alright, let's look at some more examples of rational functions. So let's look at number 4 here. We got y equals 1/4 times 1 over x plus 1 minus 4. Alright, so let's look at some transformations that happen here. This is going to be my b value. So we're basically dividing by 4, okay, which would be a horizontal compression. Okay, a horizontal compression. If we compress it horizontally, it's going to affect the graph the same way as a vertical, I guess I would say, compression. And what I mean by that is my graph is going to be closer to my asymptotes. Okay, so we have a b value, a change in the b value. We obviously have a change in my my vertical asymptote, excuse me, and we have a change in my horizontal asymptote. So my vertical asymptote set this equal to 0, so we've got x plus 1. Alright, so we know we're going to go x minus 1, so we're going to go to the left one. So we have the vertical asymptote at y equals x equals negative 1. Here is my vertical asymptote, my horizontal asymptote at y equals negative 4. So here are my asymptotes, negative 1 and negative 4. Now we can see that we did not have any transformations as far as a reflection goes, so we know graph's going to be in the top quadrant and the bottom quadrant. Now, what's going to happen to the graph, we can write my domain and range, what's going to happen to the graph is that my graph, again, is going to be closer to my asymptotes. So a vertical stretch is going to get it farther away from my asymptotes. A vertical compression or a horizontal stretch is going to get it closer to my asymptotes, which in this case we had a change in the b value, which basically affects the graph in the same way. So negative infinity to the range goes to negative 4, union with negative 4 to infinity. Alright, so your graph's going to look like this. So let's find our intercepts, x-intercept. We're going to plug in, let's find our y-intercept first. So we're going to plug in 0 for x. So we've got 1/4 times 1 over 1 minus 4. So this is 1 times 1/4 minus 4. So 1/4 minus 16 over 4 is going to be negative 15 over 4. So 0, negative 15 over 4. So again, it's going to be a little bit over 4. Bam, there it is. Alright, our y-intercept. Just found it. What am I doing? There. Let's look at our x-intercept. So set 0 for y. Let's figure out where we cross the x-axis. So 0 equals 1/4 x plus 1 minus 4. So let's multiply by, or let's add 4, excuse me. So 4 equals 1/4 x plus 1 over 1. Alright, so we can multiply by 4 over here to cancel that out. So we get 16 equals 1 over x plus 1. So 16x plus 16 equals 1. Subtract 16 on both sides. We get 16x equals negative 15. Divide by 16 on both sides. And we get negative 15 over 16. 0. So not quite 1. Now let's look at these intercepts, right? Because this intercept is very, very close to 1. Negative 15 over 16. Well, negative 16 over 16 is negative 1. Again, it's not going to be negative 1 because my asymptote's at negative 1. Alright? Well, this intercept is going to be almost to 4, right? Negative 15 over 4. Well, negative 16 over 4 is going to be 1. Negative 4, excuse me. So it's going to be real close to negative 4. So it's going to be real close to that asymptote again. So it's going to be very, very close to my asymptotes. That's how this value affects the graph, right? Alright, we're going to skip number 5. Let's go to number 6 and let's look at some transformations there. So number 6, obviously we have a vertical stretch there. We have a reflection here. We have a translation to the left 1 unit and up 4. So up 4 units, bam, there it is. There's your horizontal asymptote at y equals 4. We know we went left 1 unit, so we went left 1 unit. Bam, there it is at negative 1, so x equals negative 1. Domain, negative infinity to negative 1. union with negative 1 to infinity. Same thing for the range, negative infinity to my horizontal asymptote at 4, union with 4 to infinity. Now we know we have a reflection and a vertical stretch. So a reflection, the graph's going to be in the bottom right quadrant, and a vertical stretch is going to move it a little bit farther away from my asymptotes. So let's look at our intercepts. Plug in 0 for x, find our y-intercept. So here we go. We have negative 2 over 1 plus 4. So y equals negative 2 plus 4. So y equals 2. So we have an intercept of 0, positive 2. So go over 0, go up 2. Bam, there it is. Alright, let's look at our x-intercept. So we have 0 equals negative 2 over x plus 1. So let's go ahead and move the 4 to the other side. So it's going to be, instead of a 0, it's going to be negative 4. So it's going to be negative 4x minus 16 equals negative 2. Let's add 16 to both sides. We get negative 4x equals positive 14. So negative 4x equals 14. Let's divide by negative 4. When we get x equals negative 14 over 4, we can divide by 2. We get negative 7 over 2. So x equals negative 7 halves, 0. So negative 7 halves, negative 3.5. Bam, there it is. Alright, so here we go. Graph would look like this. Graph would look... Sorry, that's why it doesn't make sense. Negative 4 equals negative 2x plus 1, not 4. My bad, my bad. Trying to work too fast. Negative 2 over x plus 1 right here. Okay, again, I moved that 4 to the other side. That's where I got the negative 4 from. Equals negative 2 over x plus 1. Alright, now let's try again. So again, we're going to multiply by x plus 1. So we've got negative 4x minus 4 equals negative 2. Let's add 4 now to both sides. We get negative 4x equals positive 2. Let's divide by negative 4. We get x equals negative 1/2. Now that makes sense. Negative 0.5, right? Bam, there it is. Awesome. Okay, there we go. That makes sense. Alright, and the other part of that function would be right there. Alright, let's look at this. Part 2 says write a rational function in the form blah using the given asymptotes, right? Well, we know the h right here is going to move it right or left. We know the k is going to move it up or down, so we say right, left. We know the k is going to move it up or down. Now, what does that mean about the asymptote? So we're moving it right or left. This is going to be my vertical asymptote. If we're moving it up or down, this is going to be my horizontal asymptote. So if we're going to write a function where my vertical horizontal asymptote is at x equals 3, and my horizontal asymptote is at y equals negative 4. Same thing here. Vertical asymptote, x equals negative 2. Horizontal asymptote, y equals negative 5. Vertical asymptote, x equals 0. And horizontal asymptote, y equals 8. So now we've got y equals 1 over x minus h plus k. Alright, so we're plugging in my vertical asymptote. It's going to be a positive 3. Well, it's already a negative right here, so we keep it a negative. So instead of that being an h, now we're going to plug in 3. And my y value is going to go down 4 units. So this is a positive k, so we need to make it minus 4. Same thing here. Let's go ahead and write our form. Y equals 1 over x minus h plus k. Horizontal asymptote is going to be right here at the k value, so minus 5. And my x value is going to be a negative 2, so minus negative 2, because it's x minus h, so minus negative 2 is going to become positive, right? So y equals 1 over x plus 2 minus 5. Last one, number 9, we've got y equals 1 over x minus h plus k. K value is going to be positive 8, so let's make it an 8 right there. The h value is going to be 0. Sorry, the h value is going to be 0, so x minus 0 is just x, right? So we get y equals 1 over x plus 8.